I'm back here with our next problem. This is another infinite series of this. 15 plus 15 times 1/7 plus 15 times 1/7 squared. Very handily, they've actually given you a bunch of things that you need here. We're going to write those out here. The first term, t1, is equal to 15. The common ratio, 1/7. Very handy. And they want the infinite sum of this. Again, they've listed it in fractions. Notice here these terms are all positive. So this term here, this is not going to be an answer because it's a negative answer. And they've listed them as fractions, so we don't have to multiply it all out and divide it out into decimals. We'll put it in fractions as well. Let's take a look at the formula here. The formula for the infinite sum is equal to the first term, t1, times, I'm going to put a great big brackets here, 1 minus r to the n all over 1 minus r. Notice here, if r is less than 1, or it's bigger than -1, less than 1, this term here, when you go to a very, very big number, it's going to be 1 over 7 to a very big number, let's say 100 or 1,000,000. This is going to be a huge number in the denominator, so this term is basically going to be 0. So we ignore this term. So for an infinite series, this becomes 0, and we're just left with the first term all over 1 minus r. Very simple and straightforward, but just to realize it's the same formula as the one for a finite series. T1 is 15 in this case, divided by 1 minus 1/7. We've got some fractions to work with here. Let's do that. 1 would be 7/7, so this would be 7 over 7 minus 1/7 gives me 6/7. So I'll put 6 over 7 here. Now we have a division with fractions, which all of us love. 15 divided by 6/7, divided by 6 over 7. Flip and multiply. This is 7 over 6 times 7 over 6. We can do some cancellation here. We don't even need to use our calculator. This is 3 times 5. This is 3 times 2. Cancel one of those with this. We're left with 5 times 7, 35 over 2. Let's see if one of these is 35 over 2. Right over here. Here we have the infinite series with the first term being 15, the common ratio being 1/7, and it adds up to this. That's the end of this video. I'll see you in the next one as we continue on with geometric sequences and series.